Welcome to today's lecture where we're going to talk about the composition of matter. We're going to start with atoms and the parts that make up atoms, protons, neutrons, and electrons. We're then going to talk about the elements on the periodic table. We're going to talk about what happens if we have different numbers of neutrons and electrons in an atom. We form ions and isotopes. And then finally we're going to talk about bonding and how we form compounds within these atoms. So let's start right here with the parts of an atom, okay? Within atoms we have three parts: the proton, the neutron, and the electron. Protons have a positive charge within the atom. They reside within the nucleus, so within the center of the atom, and they actually have a mass unit number of 1. Okay. So when we start talking about atomic mass, each proton has 1 mass unit. Okay. Neutrons have a 0 charge, so they have no positive or negative charge. They're neutral. They reside within the nucleus, and they also have a mass unit of 1. Electrons have a negative charge. They're outside the nucleus. They kind of float around the outside of the nucleus. And they have a mass number of approximately 0. Okay? So a mass unit of approximately 0. So basically, they have ultimately no mass within the atom itself. Okay? So if we start taking a look at the actual structure of an atom, we're going to have protons on the inside the nucleus, okay, are positive charges. We're also going to have some neutral charges in there. We're going to have some neutrons, and we might have the same number, we might have a different number, okay, but we're going to have protons and neutrons inside the nucleus. Then what we're going to have are some electrons floating around the outside. And these electrons are going to want to sit about with the same number as there are of protons, because we want our atoms to be neutral in charge for the most part. Normally they're neutral in charge, but then they will change charges by gaining and losing electrons. Okay? So if we have a neutral charged atom and we have 4 protons, then we're also going to have 4 electrons kind of floating around the outside of the atom. Okay? And so this is kind of the structure of the atom. We're going to have the nucleus with electrons floating around the outside of it. Okay? Now, when we take a look at the periodic table, we can actually determine a lot of these numbers of things, protons, neutrons, and electrons, from the periodic table. Each element on the periodic table consists of atoms. Each atom is going to make up 1 element. What determines what an element is the atomic number, which you're going to see at the top of the element, okay, on the periodic table. Now, on the periodic table, you're going to see these elements in the middle with their symbol. So C is going to represent carbon, O oxygen, and every other element has different symbols to them. They also each have their own atomic number. Okay, I've put the atomic number here in red. So the atomic number of carbon is 6, and the atomic number of oxygen is 8. There's also a mass number on the periodic table. Carbon has a mass number of 12.011, which would round to 12, and we're going to talk about that rounding in a little bit. And then oxygen has a mass number of 15.999, which rounds to 16, and again we're going to talk about that in just a minute. Okay? This can help us determine how many protons, neutrons, and electrons make up these atoms, which is going to be important when we start talking about bonding. So the atomic number is actually going to tell us the number of protons, and if it's a neutral atom, that means it's also going to be the same number of electrons. Okay? So carbon has 6 protons, oxygen has 8 protons. The mass number is going to give us the total number of protons and neutrons, because if you remember from before, the mass, each proton and neutron has a mass unit of 1, which adds up to this mass here. So carbon's going to be 12. We're going to round it to 12. And in a regular atom of carbon, there would be 12 protons and neutrons together. If we subtract the number of protons from 12, so if we subtract 6 from 12, that tells us that there's also 6 neutrons. Same thing over here with oxygen. Oxygen has 8 protons with 16 protons plus neutrons. So if we take the 16, subtract 8 from it, it tells us there are 8 neutrons within the atom. Okay, so from the periodic table you can determine if an atom has what number of protons, neutrons, and electrons it has. An ion would be an atom with a different number of electrons. So if it's charged, if it has a positive charge, it's going to have less electrons, okay, than normal. If it has a positive charge, it's going to have less electrons than it does protons, because if we have 6 protons, so 6 positive charges, and if we only have 5 negative charges, we're going to have a charge of plus 1 plus, okay? So we're going to have a positive charge to this atom, which means we're going to have a loss of an electron. It's just the opposite. If we gain electrons, we're going to have a positive charge. A negative charge if we gain electrons. Okay? When we gain electrons, it's a negative charge. When we lose electrons, it's a positive charge. Okay? Isotopes, on the other hand, are atoms that have a different number of neutrons. So that's going to be a different mass number. So if you have, many of you may have heard of carbon-14 before. Carbon-14 actually has a mass number of 14. Okay? So when we take the 6 from the 14, we actually have 8 neutrons. And that's what an isotope is. We're going to get into isotopes a little bit later this year when we start talking about radioactive isotopes and radioactive decay and radioactive dating of things from way before in time. All right, so how do we get all the different compounds that we have on Earth, like water or sugar or salts and everything else that we have is from bonding, okay? Atoms want to be happy. To be happy, they have to have each layer of their electron shell, is what it's called. Each layer wants to be full of electrons. If it's not full of electrons, it's not going to be happy, okay? So, let's say we have oxygen here. We just talked about oxygen, and oxygen actually has 8 electrons total. So, the first layer wants to hold 2 electrons, 1, 2. So that's going to be full. We fill from the inside out. Okay, so we're going to fill our first 2 first, and then we're going to fill this outside layer. Well, there's 8 to fill this outside layer, but we only have 8 total, and we use the 2 here. So right now, what's happening is oxygen actually has 2 spots for electrons that are not filled. So oxygen wants to join with something else to make it so that it's going to be happy, okay? If it finds something that wants to make one more bond, it might make 2 joins. Oxygen likes to do a lot what's called covalent bonding, and it's going to share. So for instance, with a hydrogen atom has 1 electron. So our hydrogen atom here, if I draw one here, is going to have 1 electron, but not have a second one. Okay? Have an open space. So it wants 1 more electron also. So if oxygen and hydrogen actually share these 2 electrons, hydrogen can share this one and have 1. Oxygen can share and have an extra 1 in there. And then if we have another hydrogen over here, it's going to do the same thing. It's going to want to share. Okay? So we add this, it shares these 2 basically, okay? And what you end up with is the sharing of electrons, which is called a covalent bond, okay? A sharing of electrons is called a covalent bond, okay? Now, and this would be actually a water molecule. Now, on the other hand, if we have another element which is only missing one electron, okay? If it's only missing one electron, one of the things that these atoms like to do if they're missing one or they have one extra electron is they will actually take one from another atom, okay? And so if we had one that had an extra and one that has one less, the electron is going to go into here from the other atom. Okay, let's say we had an atom here that only had 3 electrons. Okay, this atom, if it only has 3 electrons here, 2, 3, it's going to be very hard for this atom right here to try to gain or share 7 more electrons. So what this atom's going to do is it's going to send this electron away. It's going to become an ion. Now we lost an electron, so this one is going to become a positive ion. And then this atom might pick up that electron. Well, if this atom has 9 protons, it just picked up a 10th, it's now, electrons, sorry, 9 protons, so it's got 9 electrons. It just picked up an extra electron, so it's now going to have a negative charge. This is called an ionic bond when this happens and then they join together because of that, negative and positive. So we know about magnets, negative and positive like to join together. So if we have a negative and a positive, they're going to want to join together and you're going to get what's called an ionic bond. So we just covered the basics of the composition of matter. I know most of this is probably going to be a review from middle school. Hopefully it is. We can get to class, we can start jumping forward with the other things. So we talked about atoms, what makes up the atoms, the elements and the periodic table and how we can determine the numbers of protons, neutrons, and electrons, what an ion is, what an isotope is, and how we can actually bond to form compounds.